The most sensitive electronic nose ever has been built by scientists in Belgium. The portable e-nose uses spongy structures called metal organic frameworks to pick up tiny traces of molecules, including harmful nerve gases. I'm Lučka Bibic, and I spoke to inventor Rob Amelot.
What we did is we looked at a new class of materials. They're called metal organic frameworks, or MOFs in short, and we tested them for use in a new type of sensor. So what people have previously been doing is studying these materials for gas absorption. So what we've been doing is developing a method to deposit thin films of these materials and then testing them in a sensing chamber.
What Rob and his team have developed is an electronic nose that resembles a breath analyzer. But the kicker is that it is extremely sensitive. Their e-nose uses this metallic organic framework that it can absorb and flag very low quantities of the nerve gases like sarin and pesticides. You could apply the framework as a film on an existing circuit and simply use your handy smartphone to spot chemicals. But what exactly does Rob mean by metal organic framework?
So a metal organic framework, I guess the best analogy would be if you go to a playground and you see one of these jungle gyms or climbing frames, that's exactly what it is. But instead of metal bars, the lattice of a metal organic framework is made up of molecules. So the holes you have in the metal organic framework, they're only about 1 nanometer wide. To give you some reference, that's 100,000 times smaller than the diameter of a human hair. These are like tiny chambers. And similarly for people, it matters what's on the walls of these rooms, right? Because some people, they like flower wallpapers, others don't. And the same is true for molecules. Certain molecules like certain chemical groups on the walls of these pores, and others don't. So the power of these MOF materials is that we can keep the size and the shape of these cavities the same, but we can change the chemical wallpaper, if you will, so the functionality on the pore walls.
Why are you calling your device electronic nose? What is nosy about it? Does it look like nose or?
Not at all look like a nose, but there are some similarities. So in the human nose, there's a patch of skin in the back of your nose. It's called the olfactory epithelium. So it's just a skin patch, but it's covered with a layer of very special receptor molecules. So these are neurons that bind specific molecules in the air you breathe through your nose. And what happens if a molecule binds to a neuron is that it sends a signal to your brain. So what we're trying to do is to mimic this binding of molecules to receptors to capture specific molecules.
Oh, and how quickly can a gas be detected by your sensor?
In our current chamber where we do the testing measurements, we can detect it within, let's say, 1 minute. And that would give you enough time to actually leave the space where this molecule is detected.
How can this sensor make a difference in my life?
Okay, well, there are actually a surprisingly large number of cases where you need to detect a very low concentration of a gas molecule in the air around you. One example would be chemical warfare. Other examples are smelling food that's gone bad, or indoors ensuring that there's enough ventilation in the room, for instance by monitoring the carbon dioxide concentration.
So Rob's electronic nose is able to detect not just whether the food has gone bad, but also other harmful gases. How sensitive really is this device?
We were looking at how we can detect sarin, which is a nerve agent used in chemical warfare. Oh, so the concentrations we're looking at are really low. So typically this is expressed in parts per million or parts per billion even. So that means you're looking at one molecule in between a billion other ones. I guess you could compare it to a small drop in an Olympic-sized swimming pool.
So is a police dog able to sense these gases now?
That's a good question. I was reading about this recently that after 9/11, there have been programs in the US where police have been training so-called detector dogs. But if you think about how you would do this in practice, where you would want to monitor continuously, let's say, a subway station or siren, that means there would always have to be a dog and a handler there, which is very expensive. And I imagine that if you would want to monitor for different substances, so a range of substances, you would have to train your dog, maybe even different dogs, so it would be possible, but very expensive. And what we're trying to do is to make this in a digital format that can just sit on the wall and would give you an alarm when it's necessary.
So clearly Rob's device has many uses. But this got me thinking, could it also be used to diagnose diseases?
What we're trying to do now is to make these sensors smaller, cheaper, and able to detect more molecules. Or eventual goal would be that they could be as small as to fit in a smartphone even. So you could maybe even do a preliminary screening with your phone, and if your phone tells you to go see a doctor, then of course you would do that.
That was Dr. Rob Amelot at KU Leuven in Belgium.